Welcome to the short video on interfacing DAC to 8051 microcontroller. Microcontrollers are used in variety of applications like measuring and controlling many physical quantities or many physical phenomena running around like that of the pressure, temperature, speed, whatever be it is. And in all these systems, microcontrollers generate the output to control the field equipments. These field control system requires only the analog signals. They do not accept any digital data. But the output from the microcontroller is the digital data. These digital data has to be essentially converted to an equivalent analog value. And to convert this digital to analog value, a suitable DAC is needed. Here you can see the pin details of a digital to analog converter 0808, which is a 16 pin IC. Here A1, which is definitely the 0th bit from the output, is treated as the MSB connected to the pin number 5. And A1, A2, A3, A4 up to this A8 represent the D0 to D7 pins, where D7 would be the LSB and D0 would be the MSB. The VCC and ground pins are self-explanatory, and VEE is the reference voltage pin, which is available at pin number 3. Output, which is in the form of current, in the pin number 4 you can see, and the reference voltage to generate the output are given through pin number 14 and 15. Pin number 16 holds a compensation capacitor connection. This is a short description list of all the pins of DAC 0808. Output voltage from the DAC is according to the equation given here. V0 is equal to V reference into all the datas. But the analog voltage is to be converted from the analog current which is given out from this DAC 0808. To convert from the current to analog voltage, one current to voltage converter circuit has to be used in the output pin. And more generally, this is done by a op-amp 741 IC configured to convert the current to voltage. If the data given by the 8051 is a 00H with the reference of say the 10 volts here, the output generated would be calculated like this, wherein all the bits are replaced by 0. Therefore, the V0 which is given out will be definitely 0 volts. 0 volts. If the data generated by the 8051 is 80H as given here, all the values are replaced, all the values are input in the form in the equation like this, and which will be giving out the voltage of 5 volts as shown here in the equation. For different values of the digital output, different voltage levels will be generated, and a sample table gives a few details of those digital data and the analog equivalent value of the voltage. Figure shows the interface diagram of 8051 with a DAC 0808 with the current to voltage converter, and this is a complete circuit diagram of interface of 8051 with DAC 0808. The digital data given out from a port, and here in this case it is taken out from the port 1, is connected to D0 up to this D7. With a start of conversion pulse given to 0808 IC, the given digital input is converted into the analog current, which is taken out from the IC and led to or supplied to the current voltage converter 741 IC circuit. This 741 current to voltage converter will be converting the input current to an equivalent output voltage V0, the value of which is according to the equation that we discussed in the previous slide. The V reference plus and V reference minus are calculated to generate a particular output current, and in this case it is given as 10 volts. The maximum current to be given out through this output line will be equal to the value of the voltage connected here divided by the resistance it is leading into. Therefore, with the required level of the current, you need to design the proper voltage and the resistance connected to this IC. The ADC 0808 uses the R2R ladder type of conversion circuit, which is the most precision circuit to convert any digital value into the analog value. ADCs are more generally used to generate different varieties of waveforms. Waveforms such as ramp, step, triangular wave, even the AC signal, the pseudo AC signals can be generated using this DAC interfacing with 8051 microcontroller. To generate the step waveforms, staircase waveforms, the program has to be properly written that the output voltages are not uniform, they are at different levels. Different level of digital data outputs will be definitely generating different level of analog outputs. And in between each level of the data, a time delay has to be properly provided so that the staircase functionality is clearly displayed on the display device such as a CRO, which is interfaced after the current to voltage converter output. The program can be equally be designed to generate the ramp function like this, wherein the output will be continuously changing. And in the previous case of step function output, the outputs are changing at intervals. For this ramp function, the output is continuously changing with a very minimum delays. And all these programming sequences are available with you, which I have provided during the class timings. You please refer to all those programming details and try to explain the things as briefly as you can. Thank you.